Today we're going to discuss how to find absolute maximums and minimums. And as we discussed yesterday, this idea is related to the first derivative of some function. Absolute maximums and minimums can occur at critical points. And we will define critical points as being three different kinds of points. So one, they are endpoints. When we're asked to find an absolute maximum or minimum, that will always occur on a closed interval. So they could occur, the highest points or the lowest points could occur at the endpoints of our interval. 2, whenever the first derivative equals 0, you could have a critical point. 3, whenever the derivative is undefined, you also have a potential critical point. Consider for a moment the absolute value function. It has an absolute minimum at y equals 0, and the derivative there is undefined. So that would be why we would need to consider, one example of why we need to consider when the derivative is undefined. Let's approach this by way of example. So first, let's consider the function f of x equals 3x squared minus 24x minus 1. And we're looking at this on the interval from x equals -1 to x equals 5. Well, first let's gather up all of our critical points. So we already know our endpoints, -1 and 5. We'll have to test those. Let's also look at the derivative. The derivative of our function is 6x minus 24. This derivative is always defined, but it does equal 0 when x equals 4. This means that I have three critical points that I need to consider. I do need to know what's the value of the function when x is -1. I also need to know what is the value of function when x is 4. And finally, what is the value of the original function when x is 5. When I substitute -1 into the original function, I get 26. When I substitute 4 into the original function, I get -49. And when I substitute 5 into the original function, I get -46. This means that the absolute maximum occurs at x equals 1. So if the question is, where does the absolute maximum occurs? The absolute maximum occurs at x equals 1. If the question -1. If the question is, what is the absolute maximum? Then the absolute maximum is 26. So again, where does it occur? It occurs at x equals -1. What is the absolute maximum? The absolute maximum is positive 26. We can also see that the absolute minimum occurs where x is 4, and the absolute minimum value of the function is -5. Where is it? It occurs at x equals 4. What is it? It is -49. Let's look at a second example. In the second example, we're considering the function f of x equals 6x cubed minus 6x to the 4th plus 5 on the interval -1 to 2. We've got our endpoints. The derivative of this function is 18x squared minus 24x cubed. And I'd like to know where that derivative is equal to 0, because it's always defined. If I factor this, I can factor out 6x squared, and I'll be left with 3 minus 4x. I want to know when that equals 0. And it equals 0 at x equals 0, and x equals 3 3/4. So for this problem, there are 4 critical points. I need to evaluate what's the value of the function when f is -1, what's happening when f is 0, what's happening when f has the value of 3/4, and finally, what is happening when f has the value of 2. When I substitute those values into the original function, I find that f of -1 is -7. I find that f of 0 is 5. F of 3/4 is about 5.632, and f of 2 is -9. This tells me that the absolute maximum of the function occurs at x equals 3/4 and is about 5.632. So that's where it occurs and what it is. And the absolute minimum of the function occurs at x equals 2 and is -9. Let's consider example 3. For example 3, if you haven't started doing this already, I would encourage you to do the problem yourself. Pause the video, do the problem yourself to see if you can do it. So assuming you've already done it, we have our interval for f of x equals 3x to the 2/3 minus 2x plus 1. And I need to find the derivative of this function to find the other critical points. I get 2x to the -1/3 minus 2. And I'm going to rewrite this as 2 over x to the 1/3 minus 2. I want to know, when does this equal 0? I also need to know if the derivative is ever undefined. And I can see, based on this denominator, that one critical point will be when x equals 0. If I solve this derivative for when the entire thing equals 0, well, I'll get 2 over x to the 1/3 equals 2. So 2 equals 2x to the 1/3. So 1 equals x to the 1/3, which means that x must equal 1. So I have 4 critical points in this case as well. My endpoints, so I need to test when f is -1, when the derivative is undefined, in this case at f of 0, when the derivative equals 0, in this case at 1, and my other endpoint, in this case at 8. When I substitute these 4 values back into the original function, I get that f of -1 is 6, f of 0 is 1, f of 1 is 2, and f of 8 is -3. This means that the absolute maximum occurs when x is -1, that's where it occurs, and it is positive 6, is positive 6, that's what it is. The absolute minimum occurs at x equals 8, that's where it occurs, and the absolute minimum value of the function is -3, that's what it is. There's one more example. For this last example, again, I'd encourage you to try it yourself and then see if you have the correct answer. We have the function sine squared x plus cosine x on the interval from 0 to 2 pi, so we have our endpoints. And we'll consider the derivative. The derivative of sine squared x is 2 sine x cosine x by the chain rule, and the derivative of cosine x is negative sine x. We need to know when this equals 0, because it's always defined. I'm going to factor sine x out, and that would leave me with 2 times cosine x minus 1. So I've got a couple things. I need to know, when does the sine of x equal 0 on the interval from 0 to 2 pi? So if I consider just quickly the unit circle and sine being a y value, then this would occur at 0 when x equals 0 and x equals pi. That's when the sine is 0. 2 cosine x minus 1 equals 0 whenever 2 cosine x equals 1, or whenever the cosine of x is 1/2. And this would be one where you really just need to have the table memorized. The cosine values are positive 1/2 when x is pi thirds, and it's also when x is 5 pi thirds because of the reference angle. So we have multiple critical points in this case. So we'll need to know some things about f of 0. Next would be f of pi thirds, f of pi, f of 5 pi thirds, and finally our other endpoint, f of 2 pi. When we substitute these values into the original equation, we find that f of 0 is 1, f of pi thirds is 1.25, f of pi is negative 1, f of 5 pi thirds is also 1.25, and f of 2 pi is 1. This means that we have absolute maximums in two different locations. The absolute maximums occur at x equals pi thirds and x equals 5 pi thirds, and the absolute maximum value is 1.25. The absolute minimum occurs at x equals pi, and it is negative 1. So there you have some examples on how to find absolute maximums and minimums of a function on a closed interval.